Okay, here's another one that we need to guarantee that triangle MNO is congruent to triangle MLO. And then which theorem? So when you're talking about guaranteeing triangle congruence, it's talking about something being equal. And in this case, we only have two expressions available. Yes. I'm recording. So you have a 90-degree angle and you have this side. If you look in both triangles, this side MO, it's a shared side, so that's a reflexive property. But in both triangles, it's also the hypotenuse. So if you think about the hypotenuse, the 90 degrees, and then this side, we're going to be doing hypotenuse leg. So to guarantee that these are congruent, triangle MNO and triangle MLO, you have to set them equal to each other. So 5x minus 8 is NO. That has to be equal to LO because NO is here and LO is here. They're corresponding parts, and corresponding parts are congruent. If things are congruent, they're the same. If they're the same, then they're equal. So in this example, we can go through and pick on the little guy. Subtract x from both sides. 4x minus 8 equals 6. Add 8 to both sides. What's she doing? 4x equals 14. Lily is very interested in this. So when you divide both sides by 4, you end up with 3.5. X equals 3.5. So that's a decimal. That seems strange. So if you want to plug it in, try it. Plug it in and see if it works. That's the beauty of math, is that you can know if you're right or wrong. So when you have 5x minus 8 over here, that's really 5 times 3.5 minus 8. 5 times 3.5 is 17.5. Minus 8, 9.5. So NO is 9.5. Here, this side LO is x plus 6. So if x is 3.5 plus 6, then that's 9.5. So yeah, a decimal is weird to get, and this whole thing felt weird when you got to 4x equals 14 because it's not going to work out in a pretty way, but it still works. When you plug this in, your measurements are equal. So if they're congruent, they're the same, and if they're same, they're equal. So x is going to be 3.5. By the theorem, hypotenuse, leg. Angle, side, side. But we can't have angle, side, side, so you have to look, is it 90 degrees? Then it's hypotenuse, leg. All right, this proof isn't like anything we've done so far, but it shouldn't make you uncomfortable because you know all the material already. Maybe not the first blank. You're given that angle H is congruent, or angle H and angle J are right angles. That HG is congruent, or oh my goodness, is parallel to JI. So HG is here, and JI, those are parallel. The transversal is GK. I'm going to draw these out a little bit so you can get an idea of where we're going with this. Anytime they're talking about parallel lines, they're talking about some kind of angle. I is the midpoint of GK. Bless you. So that's all the given information. It then tells you, so your paragraph proof starts, it is given that angle H and angle J are right angles. So H and J are congruent because all right angles are congruent. Now, the thing that I haven't marked on here yet is the other information we know, mainly because Lily was sneezing and so I got distracted because it was cute. These two pieces are congruent, and that's because the definition of midpoint. Now, when you're looking at these two parallel lines cut by a transversal, you know it's talking about some kind of angle. A lot of times they're alternate interior angles, but in that case, that doesn't help us at all. But we do have these angles are both part of the triangle, and those angles are corresponding angles. So going back to the proof, it says because that these lines are parallel with the transversal, then HGI is congruent to JIK because corresponding angles are congruent. I is the midpoint of GK, so that's something else that was given to us. So GI is congruent to IK. Why were we able to mark those right? That was the definition of a midpoint. So now you're talking about a triangle congruent to a triangle. Therefore, a triangle GHI is congruent to triangle IJK. That's what we're trying to prove. When you're talking about a triangle congruent to a triangle, you want to think back to those theorems that we've talked about. Yes, this is a right triangle. This is a hypotenuse, but no leg is given. The legs are parallel, but no leg is given. So you can't use hypotenuse leg. You have an angle marked, and a side marked. So you have an angle, and a side. When you think about all the triangle congruency statements, angle, side, angle, angle, side, side, angle, angle, side, and HL, the ones that have two angles, angle, side, angle, and angle, side. Is the side between the two angles, is it the included side? No. So it has to be angle, side. That's how you'd finish that paragraph proof. Now I'm trying to stop this recording, but I can't figure it out, and I just did it last time. I have no idea how to get this to stop. I hope I can figure out how to edit this out. But I don't know if I can.